So let us consider example 6 on how to form a PDE by eliminating the ability constant. The question says we should form a PDE by eliminating the ability constant P and A in this given relation. We have Z is equal to A exponential to the power of PT sin PS. We have to what? Eliminate P and A. How are we going to form a PDE by eliminating what? Ability constant from this given relation. So what do we have there? Remember that how many arbitrary constants, elementary constants we have there is P and A. It means we are differentiating twice. We are differentiating with respect to X, then we are differentiating with respect to T. In this case, we are having X and T. So T is in place of what? Y. Remember that the one we are doing before, we are differentiating with respect to X and Y. But this time around, we are having what? S and T. So let us solve the solution. Let us solve the question together. A exponential pt sin ps. I can name this one to be equation 1. I'm going to devote differentiating equation 1 with respect to x partially or differentiating partially with respect to 1 in equation 1. Either way, if I differentiate z, I'm going to have there z all over what? There x, because I'm differentiating with respect to x is equal to, if I take this one, this is a product a exponential pt. Differentiate this, what am I going to have? Remember, suppose I have sin px, sin 5x here. If I differentiate 5 here with respect to x, I'm going to have 5, then what? Cos 5x as this. But what do I have here? I have p, so it means I'm going to have p cos ps. Using chain rule, I'm going to get this. So if I differentiate sin ps here with respect to x, I'm going to have, if I differentiate x here, 1 times p, I'm going to have p. I'm going to differentiate it with respect to x. Then p, then cos what? Cos ps. Followed by what? Plus, I'm going to take sin ps, then differentiate a exponential pt with respect to what? Respect to x. Respect to x. You can see from here that there's no x here. It's going to be a constant. And if I differentiate a constant, I'm going to have what? 0. There will be 0. So what's my answer? A exponential pt, then multiply by what? P. I can start from AP exponential pt. Alright, P exponential pt, then what? Cos ps, then plus 0. So second, my next word to differentiate partially with what? With respect to t. Differentiating, I can name this one equation 2. Differentiating partially with respect to t. With respect to t. Let me write it full. With respect to t. With respect to t in equation 1. If I differentiate with respect to t, I'm going to have there is z over what? Dt is equal to, take all this one, a exponential pt. This one, I assume this one is u. This one is u. I'm taking u. I'm consider this one as v. If I take a exponential pt and I differentiate sin ps with respect to t partially, so it's going to be 0 because there's no t in that word in the given relation. So it's going to be 0. Plus, take v, that is sin ps. Then I'm differentiating what? I'm differentiating this one with respect to t. Remember that whenever we have exponential, I'm going to differentiate the power of exponential, then multiply by everything. If I differentiate t, I'm going to have 1 times p, I'm going to have p, multiply by everything. That is p a exponential pt. So my answer will now be, there is z all over dt, there is z all over dt is equal to what? A exponential pt times 0, I'm going to have 0. That is sin ps or pa exponential pt, then sin ps. We want to eliminate the absolute constant of what? T, a and what? A and p. But you can see that I still have a and p here. So I cannot substitute. And what am I going to do? To differentiate the z all over what? The x. You can see that we don't have y here. We are differentiating what? Only with respect to s and t. So there's no way we can what? We can remove our A and P as arbitrary constants here unless we take it to what? Higher degree. So I'm going to take this into the equation the S all over what? The Z over the S into what? Differentiate again. I'm going to have the square Z all over what? The S square. It means I'm differentiating the Z over the S again. So let us differentiate. If I have this one, A exponential PT, A exponential AP, AP exponential PT, then I differentiate cos PS with respect to X. It means if I differentiate P here, I'm going to have what? I'm going to have 1 times X. I'm going to have what? X. That is, if I differentiate cos S, I'm going to have minus sin X. I have P here to be what? Minus P sin PS minus P sin PS. Then plus, let us consider the second one. I take cos PS, I differentiate with respect to what? Respect to here. There's no X here. It's going to be what? 0. Here it will be 0. So what do I have here? I have, if I open this bracket, P is here. I'm going to have AP square exponential PT or P square A exponential PT, P square A exponential PT, then sin PS plus 0. Plus what? Plus 0. Remember, I want to have a negative sign. So my z is equal to minus P square A exponential PT sin PS. So what is this to differentiate this one again? If I differentiate with respect to xy, if I differentiate x with respect to y, I'm going to have 0. If I consider this one as P as our notation, and if I differentiate how again, this one is going to give me how. Remember, this one is how. Why? Because our notation for the square z over the x square is how. This one is how. This one is, here is what? The z over the s is P. So it means if I have how here, so if I want to differentiate x, my x means the square z, differentiating the square z all over what? The s, the y. That is what? My x. Or the square z over what? The y, the s. If I differentiate this piece, if I differentiate this equation 3 with respect to y is nowhere to be found. So I'm going to have what? 0, which shows that our s is equal to 0. So I can label this one as equation 4. I can label this one as equation 5. So let me differentiate with respect to t again. So it means I'm going to have di square z all over what? Di t square. So which is going to give me a exponential pt. This is our pa exponential pt sin ps. I want to differentiate this again with respect to what? With respect to p. If I take this pa exponential pt, differentiate sin ps with respect to t, it will be 0 because there is no t in this given sin ps. Plus is a product. Take sin ps, differentiate this. If I differentiate this, if I differentiate it with exponential power of t, I'm going to differentiate t as 1 times p. That is p times p. That is p square a exponential pt, a exponential pt. So I'm going to have p a times this one is to be 0. So I'm going to have p square a exponential pt, then sin ps, equation 6. So I can add equation 4 by equation 6. This is our last we differentiate. And what I can do very well to add equation 4 to equation 5, because we cannot substitute this into this. Because if you substitute this, we are going to have our constant as what? P and A. And we are told to what? To eliminate the arbitrary constant. It means I will easily what? I'm going to add equation 4, and what? And 6. So if I add equation 4 and what? And 6. So what am I going to have? It means the square z all over the s square is going to add plus what? I'm going to have a exponential pt, the square z over the s square is minus p square a exponential pt, then sin ps. That's what we get from equation 4. Then equation 6 is what? P square a exponential pt sin ps. If I add this one to this one, minus p is going to cancel p square. Then this one, take away this one from this. This is negative. This negative are averting all these things. Sin ps is going to take away this one. While yes, this one is going to take away this one. So it means my answer will be 0. So what gives me 0? It means I had the square z all over the s square plus the square z over what? The t square is equal to 0. When I had equation 4 and equation 6 together, I have what? I have this and this then, which give me 0. So what give me equation 4? The equation 4 is how is equal to minus p square a exponential pt sine ps, which is this, plus del square z over del t square, which is what? P square a exponential pt sine ps. When I had how and del square z over del t square, I have what? I have what? I have 0. It means is either I said how plus del square z all over what? Del t square, or how plus del square z over del t square, or I said del square z over what? Del s square plus del square z all over what? Del t square is equal to 0, which is the what? Which is the required PDE. Is the required PDE.